Assalamualaikum and good day to my fellow panels. My name is Arni Nabila, binti Mohd Zainuddin. My matric number is P051820039. I'm from Faculty Manufacturing Engineering. I'm under supervision Associate Professor Dr. Zaleha binti Mustafa. Today I will present my final year project 1. My title of this project is Durability of Rubber Wood Floor Plastic Composite Exposed to Accelerated Freeze Thaw Cycling. My presentation today consists of introduction, problem statement, objective, scope, literature review, methodology, and early results. Rubber wood floor plastic composite are composite materials made from wood fiber or wood floor and thermoplastic matric such as polyethylene, propylene, polyvinyl chloride, or polyatic acid. The wood fiber and plastic rubber wood floor plastic composite can also contain other lignocellulose filler material. The demand for rubber wood floor plastic composite from the automotive and construction sector for applications such as interior or exterior car parts, decking, fencing, or siding material. Rubber wood floor plastic composite are manufactured using wood fiber, a byproduct of a timber industry, and a low-cost biorenewable filler with high mechanical properties, and a polymer material that has suitable physical, thermal, and material properties for fabrication and in-service use. As a composite, the wood fiber reinforcement strength and stiffness, while the polymer matrix transfer the applied load throughout the material for construction. Rubber wood floor plastic have some advantage over competing products, but they are also susceptible to environmental deterioration mechanism. Compared to dimensional lumber, rubber wood floor plastic composite do not contain large inherent natural flaws or problem statement. Despite such advantages, rubber wood floor plastic composite are prone to deterioration from causes such as moisture and freeze thaw cycling, fire exposure, and biological attack. Deterioration of rubber wood plastic composite negatively impacts performance, limits expected service life, and inhibits consumer confidence, which prevent the widespread use of rubber wood floor plastic composite as a preferred material for suitable construction application. Currently, on weather freezing temperature in the presence of moisture cause freeze-thaw-induced damage in addition to moisture-induced damage in rubber wood floor plastic composite. The wood fiber reinforcement swells due to the absorption of moisture, and the absorbed moisture further expands upon freezing. Therefore, absorbed and consequently forced moisture can make damage in rubber wood floor plastic scopes of research are as follows. These materials are from rubber wood floor plastic as reinforcement, reclaimed wood fiber as a filler, and polypropylene as matric. Second, the fabrication method using compression molding machine. Third, the rubber wood floor plastic composite will be subjected to freeze thaw cycle up to 5 cycles at 27 degrees until negative 27 degrees. The change in the rubber wood floor plastic composite properties due to freeze thaw cycling. Exposed will be characterized by tensile, fracture testing, thermal and morphology analysis. Objective of this project is to compare the effect of freeze thaw cycling onto the mechanical properties of the rubber wood floor plastic composite. Second, to evaluate the effect of freeze thaw cycle onto the thermal properties of the rubber wood floor plastic composite. And lastly, to correlate the fracture behavior of the rubber wood floor plastic composite with their morphological analysis. Stiffness are lower than in the composite. Ali Riza Ashori investigate the using wood fiber as reinforcement to thermoplastic resins can yield composite material with increased strength and stiffness. According to the researchers, polypropylene granule and rubber wood fiber granule extruded into rubber wood floor plastic composite granule, and then the compressor molding machine were used to make a specimen. This is from Salim Hib Zero Glue. The specimen made with 7% calcium carbonate content, which the optimal level of filler regarding overall mechanical and physical properties of rubber wood floor plastic composite specimen result the highest strength of composite. The advantage of the use of natural fiber in composite are their renewability, biodegradability, non-toxicity, good insulation properties, and low machine wear. Upendra Sharan Gupta studied about a composite is a combination of two or more materials which different that can classify into plant-based and animal-based fibers are made to become a single materials. To be used as reinforcement, pure fibers need to be extracted and separated from all cementing substance and are present in a natural plant or animal raw material. Elisa Zini, wood is a fibrous composite is commonly used in a form of wood pulp. The specific mechanical properties of natural fiber come closer to those of synthetic fiber. This chapter 4 methodology. This chapter describes the process methodological of this research, which consists the principle of method that we perform to complete the research. The selection of material, processing and testing will be presented as well after refer attentively to the specification and particular of previous research. Flowchart below. First, we identify the raw material of rubber wood floor plastic composite. Since the formulation of rubber wood floor plastic composite has been optimized and extruded by Prince of Songkla University and supplied into forms of granule. A deficient chosen material can change the properties of the material and may influence the performance of the part. The flexure sample will be exposed to 3 increasing relative humidity conditions and 1 water immersion condition in humidity chamber. After reaching equilibrium, half of the saturated sample will be exposed to freezing temperature. The flexural mechanical properties of all environmentally conditioned samples were obtained to identify the cause of damage, namely only moisture or combined moisture and freezing. Second, the constituent fiber and polymer mechanical properties of rubber floor plastic composite were experimentally determined through identification and flexural testing, mechanical tensile testing, and used as model input parameter. Third, the flexural mechanical data were used to further validate a previously published micromechanical model that predict the onset of moisture-induced damage in rubber wood floor plastic composite. Lastly, after the data obtained during the test will be precisely interpreted, analyzed, and overlaid, the risk conclusion will be made by analysis done in previous part to produce an optimal product performance. The compression molding of material include 4 stages, which is: firstly, material is open heated mold. Secondly, material is compressed at high pressure to fill the hot cavity space between the two parts of the heated mold and softened and shaped, and then mold is cooled to solidify. Finally, the upper mold will open to remove the product. The compression molding has advantage, which is no spurious, but it is also have disadvantage, including small output, high labor cost, and low output rates, because need a long time to heat and then cool the material parts before the molding. The characterization: first, flagellar and tensile testing using Universal Tester Machine ASTM D638. Then, thermal analysis using differential scanning calorimetry DSC. And lastly, morphology analysis using scanning electron microscopy SEM. For freeze thaw testing, water absorption freeze thaw cycling of the composite was performed in accordance with ASTM D666201. And for testing material specimen parameter for tensile testing using ASTM D638. For early result, at figure 6, the result obtained with experimental result of mechanical properties of rubber wood floor plastic composite versus other rubber wood. A for tensile flexural strength and B for tensile flexural modulus. Figure 7, the result of an image analysis was performed to assess the microstructure of specimen. Simulated mechanical behavior will be shown on the scanning electron microscopy SEM and SEM simulation respectively as shown in figure. So that's all from me. Thank you.